Okay, I need to repeat my sentences. Sorry for that. And yeah, I was talking about this OpenTelemetry first because we will talk about Spring Boot 3 OpenTelemetry support. By the way, the OpenTelemetry, this observation distributed tracing, it was already in Spring Boot. Maybe you know about the library. It is called Spring Cloud Sleuth. And by default, if you use REST template, your request metadata is already propagated from one service to another one. Of course, if you are not doing new REST template, if you are using the existing REST template configured by Spring. Right now in Spring Boot 3.0, there is an official support on OpenTelemetry. So what is OpenTelemetry here? Okay, let me double check. Okay. In OpenTelemetry, it is all about observability. And in observability, basically, there are two things: metrics, logs, and traces. Trace is something, let's say that this is a path that an entire request just creates during visiting other services. For example, if you do place order operation, it can go to order service, then payment service, then product service, maybe shipping service. And in the end, you will see one unified path, which is called trace. And this trace also propagates some kind of metrics data. For example, request latency, response latency, this kind of things. So this metric stuff, the trace or metric stuff, it shouldn't be necessarily related to client-server topology. It can be also something like maybe your application to database. Of course, it is something like client-server, but at the end, while you can get metrics from services, something like request latency, response latency, if you are talking to database, you can also collect metrics about, okay, what is the execution time of a specific query? This is also good insight about our integration, is OpenTelemetry data. So trace is the path. When you start your request, it generates a trace ID. And then this trace ID is propagated from one service to another. For one unified request, you will see only one trace ID, but you can have multiple span IDs. Span, you can think that span is a subdivision of trace. For example, you called create order, right? Inside this create order, it can do a couple of other things. So you can name them. And for example, an operation is executed in order service. There is a span for it. When your request reaches to another service, something like payment service, the trace ID is propagated. But since it is another operation, different operation other than order service, then you will see a different span ID there. So under a specific trace ID, you can have multiple span IDs. This is the result. And when we talk about metrics, they are related to spans mostly because the metadata belongs to span, because trace is something very global, but when it comes to metrics, they should be tightly coupled with, not tightly coupled, but relate to span. So trace, metrics, what about logs? Let's say that you are interested in metrics, you check request latencies, response latencies, but what about the root cause? For example, if there is a spike in the request latency, you may want to check, okay, there is a request latency increase in a specific time interval, but what about logs? What are the possible logs there? You can take a look in the logs and say that, oh, okay, there was a third-party integration. Then in request, we got lots of timeout. That is why we get an increase in the request latencies. Maybe this is just a path of the analyze operation. Basically, if you talk about OpenTelemetry, as you can see, it is generally available across several languages. So this is not something specific to Java, Spring, or something like that. You can see this OpenTelemetry implementation in Go, JavaScript, Node.js, and other languages. For example, C++, .NET, Erlang, Go, Java, JavaScript, PHP, Python, Ruby, Rust, Swift. So if you are working with those languages, you can use this specific implementation. Maybe one information about the implementation SDKs. For example, when you check Go, you will see some kind of metrics. Let me check it here. Not SDKs. Okay. I couldn't find the part. Maybe check .NET. Okay, in these implementations, they mostly mention about this. Okay, I implemented a Go SDK for OpenTelemetry, and you can check if they have a support for trace, metrics, and logs. Maybe it has support about metrics, traces, but there is no log support. Can be possible. What about registry? So in this registry, let's search for, let's check if there is a MySQL here. Okay, MySQL instrumentation. Let this for Go. Okay, not Go, I think it is JavaScript. SQL instrument. Okay, so this is just a Python example. From the beginning of the queries, they just say in MySQL instrumenter, it is coming from the OpenTelemetry implementation, of course. You say instrument. So when you do this, basically, it just inspects your database operations. If you are using Java, most probably there is some kind of interceptor or aspect so that it just inspect your SQL queries. So especially if you are, since we are using Hibernate, Data JPA, this kind of libraries, and they already have support this kind of interceptors, maybe hooks, it is very easy for them to analyze these operations. What else? Oh, I just closed the registry stuff. What about, for example, Kafka? OpenTelemetry, Kafka instrumentation. There is something called Hotel Sarama. So most probably you can see these libraries like Hotel something. So OpenTelemetry implementation of Sarama. I haven't used Sarama, but I don't know what it is. But they have an integration for this. What about, maybe I can search for Spring. The Spring, they have RabbitMQ, Kafka. What else? They have lots of things here. Okay, if you specifically using this for course Spring, maybe you can take a look at this library, and you see there are different kind of exporters here. You basically add the OpenTelemetry API, and they have an exporter. For example, Jaeger exporter. You know, Jaeger is implemented by Uber, and it is a distributed, open source distributed tracing platform. And when you add OpenTelemetry SDK into your project, of course, it generates some kind of metrics. And if you are not shipping these metrics to some kind of collector endpoint, it is not so much meaningful, right? Because the metrics are there, but you need to take a look and maybe generate a report, analyze something at the end. Maybe you can just calculate tail latencies of your services. Okay, now let's try to use this support in Spring Boot. And again, in Spring Boot 3, yesterday I just tried this native image build support, but unfortunately it took too much time to build Docker image. So I cannot say that I am very happy with that, but at least for the beginning it is good. I believe in the upcoming months, next year maybe, it will become better and we will use it. So this is observability documentation for Spring 3, and they already mentioned about you can just create a project by using start Spring IO. This is Spring initializer. We are using our IDE, and you see, in order to follow this article, you need to add Spring Boot Starter Web first, because there should be an HTTP server at the beginning. And also create an observation by using observed. There is an observed annotation. And as you can see, this is a kind of aspect-oriented programming. That's why we will need Spring Boot Starter AOP, aspect-oriented programming. Why? Because instrumentation is something like, is very good use case for aspect-oriented stuff, right? Because think about in Spring, very popular aspect examples could be logging, request and response metrics, right? You just implement an aspect, and by default, it logs all the request data and response data in your Spring Boot application. So, aspect example. What it does, it just instruments your requests, collect data, something like what is the path, what is the parameters, this kind of things. For the response, it can also instrument your response data and take the useful ones. Here, same strategy, instrumentation, but this time it collects some kind of metrics. I cannot say that it is on the request or something like that, but if there is a HTTP client or HTTP server, most probably this observed stuff, the annotation, will collect lots of useful information. So we talk about metrics, right? And these metrics mostly related to application metrics. And yesterday we also mentioned about micrometer metrics. Micrometrics, most probably it will be it is the de facto solution for Spring Boot metrics, and it is capable of exporting metrics as a Prometheus format. They say that IO micrometer register Prometheus. So remember this actuator endpoint. In actuator endpoint, you can check how much not found error you got in this application, right? But they are all in JSON format. But when you use micrometer plugin, and especially registry Prometheus, you will see when you try to read this data, it will be in Prometheus metric format. It is something like plain text. Maybe you saw that before. But most probably we will see it. Tracing, for tracing context propagation. This context propagation is something, in Spring there's a context, right? In this context there can be lots of information, something like user session, request information. So they will be propagated to next service if you are using, for example, REST template builder. For this purpose, there will be micrometer tracing bridge Brave, but we will see it. For latency visualization, we need to send finished spans in some format to a server. In our case, we will produce zipkin compliant span. To achieve that, we need to add this one. For logs, in this example, they are using Grafana Loki. In 2019 or something like that, Grafana introduced Grafana Loki. You can think that it is a logging backend for Grafana stack. And when you take a look at Spring applications, there is something like, you heard about these logging libraries, right? Log4j. Here there is also a Loki4j and logback appender. This logback allows you to configure your logging strategy. When you say Loki logback appender, most probably this one will require some kind of Loki backend. Okay, let's check it. So this is our application properties, server port, name, application name. We say tracing sampling probability 10, that's fine. Management, so here include, when you enable Spring Actuator, by default, most probably you don't want to include everything. So here we say that only export Prometheus. There is a percentile, okay, bucket. There is a logging pattern here. There's a specific logging pattern. As you can see, the trace ID and span ID is included inside the logs. What about logback Spring? So if you put a file under resources with a format logback something.xml, as you can see, this is a configuration. This configuration is coming from logback base. You can take a look at this schema. And I see there is an appender, Loki. So here you see the appender logic is bundled inside this class Loki4j appender, and it is coming from this dependency. So if you don't have this one in your class path, you will fail. Most probably it will say that, oh, I couldn't find this class. And as you can see, there is a Loki endpoint here. What else? There is a controller. There's a service injected inside it. There's a logger, log info. Okay. There is a configuration. So this is for, this is for observed aspect in registry. Okay, what is this registry? We don't know it. There's a service. So in service, this is a service inside service layer in Spring application. When you call this username method, most probably this will do something, right? That's why we call aspect oriented. So when you say observed, there is a name here. Most probably this is the name of the metric. Contextual name, getting username. So this is very generic name. Contextual username is something like, let's say that in the dashboard, you just wanted to see something very human friendly. That refers to that one. Love coordinated key values, user type, and user type 2. There's some logs. Okay. There is also a handler. What is this handler for? Okay. The handler is for, for the observability context, you need to implement. So when you implement observation handler, you need to fulfill these message function bodies, on start, on stop, support context. Again, what I see, there are very verbose operation here. In order to use observability, you need to do lots of things. But let's see. What is this? REST template client application setup. So this is for web MVC server code. This one, REST template client application setup. So this is client application. They are saying that as before, we add web and actuator dependencies to have a web server running and micro. Okay. Prometheus, Reach Hotel. Okay, again, Loki backend, line code. So here, important point is there's a REST template in the client application. Let's say that this is order service, and the first application is payment service. You make a request or order service, and order server call payment service here. So order service is a client application for the payment service. You can think something like that. Okay, same operations, but here you are using existing REST template instance. Why? Because if you try to use new instance of REST template, it will be pure REST template. There is no interceptor, there is no instrumentation inside it. But if you try to use a REST template builder here, most probably it will take the existing REST template, which is most probably already configured by Spring itself. You see, there's a command line runner application. You know, in Spring Boot, there are different kind of applications, something like command line runner, Spring Boot application, these kind of things. In a typical client application, there is no HTTP server, right? So here, this application is calling another application. Okay, you see REST template get for object. This is the port of the first application. I don't know if they are in same application, but there is a Docker Compose up here. You need to see their Docker Compose. Let's see what they did. Their Docker Compose. There is a Tempo, Grafana Tempo. I think this is Grafana's APM solution, as far as I remember. Grafana Loki, they have Grafana Loki. Prometheus, of course, there should be a Prometheus endpoint. Grafana, this is for UI. Where is application? No? I cannot see application. You can use the Grafana Tempo stack and start. Okay. Okay. So, okay, I got it. So for the stack, they are saying that for the stack you can use this one. Okay, fair enough. Let's take a look at maybe their stack first. Here, okay, GitHub. Yep. So I hope you already see my screen, and the font is clear enough. Here, let's just create another application, right? Echo server, actuator, web, packaging jar, and let's say that hotel zip. Okay. Multiple types found with build Gradle. Oh, Gradle and format project. Use type with a more specific Gradle project. I recently upgraded this one. Let me help. Oh. Okay, I will do this. Dash type Gradle project. Okay, now Gradle project Kotlin. Okay, I said that Gradle project. Fine. So unzip. We will do hotel.zip. If we do that, okay, now we have a hotel project, right? Let's open this one by using IDE. Let me check if I have another instance. Trust project. Yeah, we only have this application. Okay. There can be some kind of JDK related problems, but let's see. So let's wait for it to finish this indexing stuff. So let's continue with, okay, so here in this project, what I will do is I will create a file, docker compose. So I will not deep dive into, or I will not try to implement this one on myself. What I will do is I will just copy this one because it is already a observability stack. Let's see if I need to do something else. So extra host, I see there is a Docker Tempo or something. Okay, most probably it will just trigger a folder related something, but at least we can see it now. Docker compose up. Okay, I hope they are tiny images, but so this is go, another go application. Okay, I believe there is no huge Docker image. Yeah, 32. So anything fancy on your end? Are you already migrating your application to something Spring 3? Or if you are using Spring Boot, which version is it on your end? And are you happy with that? Okay, so it says 1990 is already in use. Yes. Oh. It says that 1990. Okay, it is used with this process kill. Fine. Goes up. Ah. Okay. So what it says, is there any kind of README here? I see there is a Docker folder. Maybe I need to create them in advance. Okay, got it. So under Docker, Prometheus. Okay, there Prometheus. There are some files there. Let me jump here. Directory, Docker. Will it exist? Okay. It is just created by default, but this is just a folder. I need to make it perfect. Prometheus. Okay. YAML. Let's copy this one. Prometheus YAML. File Prometheus YAML. Okay. It. Okay. So here, there is a job inside this Prometheus, and the target is this one. So it is trying to collect metrics from this endpoint, and this endpoint refers to Prometheus itself. So micrometer just exports this insight about Spring Boot application in a Prometheus format, and it is collected by Prometheus itself. And metrics path, this is for Prometheus, this is for application. So Prometheus, this is Prometheus instance itself, and this is for our application. You know, micrometer plugin just extends actuator endpoint, and when you make a call to Prometheus, you can reach that endpoint. Static config, this is our application support. Okay, so Prometheus YAML is cool. We already did it. What else? Docker. There is Grafana provisioning dashboards. There is dashboard YAML. So we need to populate a dashboard. Dashboards file. Oh, dashboard YAML. This one. Cool. What else? Dashboards. There are logs, traces, metrics, JSON. Also take this one. File. Okay. What is next? Provisioning data sources. So you know data source. When you create Grafana, maybe we can mention about this technology. So Prometheus is mostly used for metrics collection, and if you have some kind of metrics, time series metrics. So in order to do some kind of specific query on a time series data, you need to have proper database for that. Prometheus is one of the popular one. And in order to make queries, we are using some special query, which is called PromQL. Prometheus is for metrics endpoint, and also it is capable for collecting other metrics. So if you have an endpoint which is compatible with Prometheus time series data, then you can just make it collectible by Prometheus. And here, metric, it can be in different format. There is, for example, gauge, histogram, time series data, this kind of things. And what was the other component? Grafana, right? Grafana is all about, Grafana UI, it is all about visualization. In order to visualize something, you need to have data, right? And for this data, what we have in Grafana, they are called data source. And in this case, we will provide Prometheus endpoint as a data source. And Grafana will populate some kind of data by using Prometheus time series metrics. should be YAML, not JSON. Okay, here data sources for the Prometheus, it is using 1990, which is Prometheus. For Tempo, it is using 3000 something. And for the logs, it is using Loki endpoint. Okay, let's move on. Grafana, provisioning, that's fine. Prometheus YAML, we already did that. The next one is Tempo. There is Tempo local YAML. Let's copy this. Where are you? Tempo local, okay. A new file. This is YAML. Okay, paste it. Okay. Let's say another Docker Compose up. We can also say Docker Compose -d so that it will be on the background. Lazy Docker. Okay, so here we have always exited. All of the files are in YAML format by ML format, but here it is not by ML. It is there is an A, extra A. Okay, let me fix it. We need to be consistent about that, right? So just do this. Okay. And stop this. Docker compose down. Okay. Lazy Docker. Okay. Now all of them are running. So if you directly clone the project, you can easily do that, but I prefer to do it myself because most of the time I learn what happens there under the hood. Next. So they are saying that in order to access Prometheus, just go here. As you can see, this is Prometheus Endpoint. Maybe request. You see there are lots of metrics here already, but it is collecting from different locations. And go back, and where are you? Oh, okay. This is Grafana Endpoint. So in Grafana, maybe it is too much to zoom. Okay, in Grafana, I haven't done anything, but when I open this one, I see dashboard information, logs, traces, metrics. Let me double check my dashboard YAML. There are dashboards, and as you can see, it is coming from here. So I really like to use GitOps notation. So whatever you have as a configuration in your application, better to not do any operation, let's say that, out of your state. So if you do configure something here in dashboard by using its UI, then on the next iteration, on the next deployment, most probably you will lose that data, right? Maybe you have some kind of storage, you may not lose it, but think about if you ship this application to another instance of, let's say that Kubernetes, then again, you will lose the data. But if it is just as a configuration, then you can deploy same thing on all of the places. Okay, there is nothing here because we don't have any kind of application, but maybe we can just analyze the other parts. So when we go to configuration section, you will see there's data sources, and in data source there is Loki, Prometheus, and Tempo itself. Okay, everything is configured already, and we don't need to deal anything else here. But when we check Docker Compose, what I see, there is, for example, here, anonymous enabled true, anonymous Oracle admin login from true. Here, they just disable all the stuff related to security concern, related to security, but in production environment, especially if you are exposing this application to outside, you shouldn't keep this application like that. So you need to somehow maybe add some kind of single sign-on in this application. Also, maybe you need to configure some kind of VPN. You can put this application behind the VPN. Better not expose this application to outside in order to reach by using domain name. Yeah, be careful about that. And okay, move on. Let's, okay, we always lose this article. Okay. You see, there are two models, right? Maybe we can follow their conventions. There is a blog post, and they have two applications, client and server, but basically they have only one. Okay, they are using multi-module project. We can also use that one, but since we are using Gradle, okay, okay. Maybe we can also convert into that notation. So here, this is a project, that's fine. Okay, let me do this. There will be, okay, I will do this. I will jump into the folder again, jgithub tel, and then Spring init. There will be a client here, client, yep, and also there will be a server. Unzip client, zip client, and server, server. Okay, just remove everything related to zip file, zip. Now we are ready to go. So server, there's client. Most probably we will remove this part, right? In build Gradle, in settings Gradle, we will have some project or something like that. Let me check the correct notation. I couldn't memorize that. Gradle. Let me zoom this. Okay, Gradle multi-module project structuring. There's an app build Gradle settings Gradle. So settings include there will be client, include there will be server, right? Just remove this data. Oh, delete and delete build Gradle. I don't need it at all. There's Gradle wrapper here, but yeah, let's stay. Double check. Let's double check. Gradle. So it is building client application. and also it is building server application. Now we have two modules, and we can access this application by using under the build libs. Yeah, we have jar files. So until this point, easy peasy. So most probably we will start with server application. I will simply follow their article and see what happens. Scrolling up here. Microphone, okay. So we don't have, most probably we will not have this one. Okay, we just created an application. They are saying that you need to add Spring Boot Starter Web. Let's check it. In server application, build Gradle, we already have web. But we need to have also, what was it? Okay, we have aspect oriented also. So you see, there is no version here. You cannot see version because it is using a parent project which is called Spring Boot project, and we are already using 3.0.0. So whatever required version we need to have, they are all managed by a parent project. Oh. Okay, let's name them here. I will rename this one to server applications. So yes, and this will be client application client. Yep. But here, delete. Yes. Okay. You see, we have client and server. Cool. And here, for the actuator, we already have actuator dependencies. Build. Yep, we have actuator. So we don't need to add it at all. So for the metrics, for micrometer metrics, Prometheus, we need to add the IO micrometer, this dependency. Let's check it if there is an autocomplete or not. So it will be implementation, the short notation, io.micrometer. Next, micrometer registry Prometheus. Micrometer registry Prometheus. It's already completed. Okay, done. What about tracing? For the tracing, they are saying that same, this time micrometer tracing, bridge, brave. Okay. Oh. This time it be micrometer tracing, bridge, brave. So refresh. This is for tracing context. For latency visualization, we will need IO Zipkin. Okay. So you know this Jaeger, Zipkin, they are for distributed tracing backend. They have an endpoint. They know what are the tracing metrics. You can send your data to Zipkin or Jaeger. Which one do you need? Whatever you need to prefer. So IO Zipkin. we need to add implementation zipkin reporter tool zipkin reporter brave. Another refresh. And for the logs, let's import this one. Com GitHub Loki 4J. Implementation com GitHub Loki 4J. Loki logback appender. Loki logback appender. Another refresh. Okay, move on. Resource application properties. So we already have these application properties, right? Server port. I don't know. So just port Spring application name. So you can also just a note here. If you are using Micrometer actuator plugin, then they require you to provide a name because this name is used for differentiating applications, right? Because you may have same class names, but if you provide the application name, then when you open the dashboard, you can see the names that you desire. Management tracing sampling probability. Let's see if there is an autocomplete from that. So management tracing sampling probability, what is it? 10. So is there anyone? What does this mean? So currently applications generate big data, right? And there is OpenTelemetry SDKs that instruments your application. So they are ditching your application. If you do something in the application, instrumentation SDK says that, oh, what did you do just now? Could you please tell me the details? Something like this. So there's a cost for this, right? You can say that to instrumentation library, oh, instrumentation SDK, just do not try to ditch every piece of application. So application says that I will do, for example, 10 operation, and I will report to you only one of them. That means the probability will be 0.1 this case. When you say 1.0, that means whatever you do in the application, they will be all reported. So this is a sampling profile. That means all the operation will be sampled. But this is the simple explanation of that. Next. Management endpoints web explorer. Okay. Management endpoint export Vertex include. So we are saying that only expose Prometheus one. So under the actuator endpoint, you can have lots of dangerous endpoints. For example, there is an endpoint for log. There is an endpoint if you expose it, anybody can just shut down your application, Spring context. So you may not want to expose them. I'm saying that only expose Prometheus. Management, okay. Just say percentile histogram. Oh, percentile histogram. True. Not auto time, not data repository. Management metrics distribution. Percentile histogram HTTP server request. Okay, so this is true. What else? There's the logging level, and I will copy this one. Okay, you see, it is referring to Spring App. Oh, Spring application name, but I provided Spring application name. So it refers to this one. This is called a placeholder. So you can use placeholder to reference from one location to another part. It is just a reference like we use in the normal programming languages. So we need to create a dedicated file for logback, right? Also, it is under the resources folder file. Just create this one. I will not try to write this one by one, but I know that there is a logging backend here. If you try to move to this endpoint, right here, most probably it will get some kind of protocol error. Yeah, error 405, not supported, so I cannot push something. I cannot do this kind of request. Okay, there will be trace ID, level, host, application, file log, pattern, info. The root level is info. That means if you say, for example, log info, they will be shipped to destination. An appender reference is this appender, which is Loki. It is using this class, and that's it. Next, move on. So in here, what it does, it just implemented the controller. Let's implement our controller also. So I don't need to create a separate file for that. What I can do is in server application, Zoom, I can put res controller here and get mapping public. What was the stuff? Okay, there is also a dependency injection here. I think we can do that. Get mapping should be user ID, string username. Okay, string username. Of course, pet variable string or integer string. Okay, user ID. So if this name matches this placeholder, you don't need to provide a something like this. Oh, okay. Then just we need to do something here. Okay, you know, very basic logger class, which is static. Or let me check SLF. Oh, we don't have it, so I need Lombok to do that. For now, let's use this static logger. Oh, we don't have it. Really? Import. Okay. Okay. So here log.info, what it says, got a request. And then it says return. There should be a private user service here. I will not do construct injection right now. Auto wired, right? It will say that there is no such a class. So let me do this class here. Class use service, and of course I will do a service annotation here. What was the function name? Username. So string username, string user ID, and okay, I will implement the remaining part, the business. Okay, let's implement this one also. So we will add this static logger here, private static logger, but this time this will be user service, and okay, okay, mm, here. Okay, we will use this observed stuff, but I don't. Okay, I need to. What it does in this business logic? Random here. It simulates a latency. Okay, it is just adds a latency here so that you will get a metric in the Loki backend. Let's do this private final random 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 is equal to new random. Okay, in string username log.info getting user of ID. They're using, and it should be info. I will put user ID here. So it's saying that, okay, I'm getting a username there. And at the end, it return, let's say that John. Okay, John. But here, at the end, at the same time, it is saying thread.sleep, sleep. And here, in the sleep statement, it's saying random dot next long. And just introduce two, I don't know, it is millisecond, and just surround with try catch. Yep. Okay. This is another method. And here, we need to use user service dot username. And what is the ID? User ID. That's it. Very simple application. And let's run this and see if we are. Oh, we haven't added. GitHub. Okay. There's a problem. I need to go to build Gradle. This one. Fresh. Com GitHub Loki J. I remember there. Search for this. Okay, it is correct. Declare repository providing. Okay. Okay, let me check what they used in their projects. It should be inside server module, server, XML. Runtime. Only for runtime. Okay, I will do this. Just search for this one, but repository. Okay, go there. Which one? Appender. This one. Just Gradle short. 132. Insert 132. Refresh. Okay, this time is fine. Server application, run it. Okay, cool. It is running. And localhost. It was it. What was the port name? Application property. This one. Okay, it is white label, but when I go to the user slash something, and I got John here. Okay. I need to take a break for 5 minutes, so I will be back soon. So I am back and let's continue. So our application is working. We already run it. As you can see, getting username of ID something. And here, do you see this info server, this trace ID and span ID? There's also application name, trace ID, span ID, and that's it. Okay. And of course, you see the thread name and also the class name. So client server application is running. What else? We don't know if it is shipping to Grafana. Let's check it here. Okay, as you can see, we saw a log, got a request, get the username of something, and here, as you can see, there is only one metric because I make a request to server and I get a response there. It took start time is on 0 millisecond and the duration is that millisecond. And you can see a couple of attributes there. For example, okay, you can hear me, I hope. There are a couple of attributes like exception, none, URL, what is the context path, what is the HTTP method there, what is host IP, outcome, and kind. So what kind of span is this? This metric specifically coming from a span inside the server application, right? This is an instrumentation happened in the server side. Status, what is the result of this request? Status code, I don't know why it is 0, but most probably it is meaningful on the client side. URI, this is the URI, I think this is specific to Spring. Resource, let's check what is resource. Service name is server. And I made only one request. Okay. So you see, since there is only one application here, we cannot talk about distributed tracing because everything happened in one application. You can see multiple. So here, I got a request. As you can see, there is a trace ID here. This trace ID exactly same with the other one, right? Let me close this one like this. It starts with 638, and here also, the second one, it also starts 638. But when it comes to span, it starts with 3B, EA, because they are in same operation. As you can see in the code base, server application, user service, and I think it's okay. But remember, we haven't put this observation stuff yet. Yeah, this one. Observed. So instead of seeing something like class name, method name, we will use this specific name. Let's start application, restart application. Click the show and start this one. Okay, and okay, a couple of requests. There are lots of trace IDs here. So refresh 5 seconds, and now for last 1 minute there is no data. There are lots of trace IDs, by the way, here. Let me check the latest one here. Okay. The example of using annotation of observed methods, username will be used as a metric name, getting username and name will be set as a tag for the metric. Okay. We are not able to see the tags yet here because we have used observed, but there is also another configuration here, my configuration. So I believe we need to add also that one. So we have user service, and let's create another one, Java class, observation config, right? And here, configuration, and proxy methods, false, okay, no worries. I will not create a separate one, don't need it. That just defines something here, right? Not public, only class. So it is saying that just declare a bean observed aspect, and there is a registry. Yes, observation registry. Observation registry. This one. Then return observed aspect of registry. Okay. Start application again. Okay. Home with the configuration. Now there is a handler, observation handler. Let's name it as observation server observation extends. No, implements. Observation there. There should be a generic there. Observation context. So we need to implement missing methods. Which ones? OnStart, OnStop, supports context, getUser, OnStart, OnStop, support context. We need to implement those. Yes, OnStart, it says some kind of this logging. Yet there is a logger also. Here, but the handler name is something different. Before running the observation context, user type, get user type from context. This is a private method, I think, here. Should be a static. The key value. It is coming from micrometer. This is the first one. So I think supports context in empty return true. Okay, I will restart the application, stop and rerun. Okay, they are changing actually. When I check timing, last 5 minutes. Okay, there is no such a thing. There should be at least one trace ID. That's why. Okay. Now client application setup. Spring Boot Starter Web Web and Actuator is already there, so we can use it. Prometheus. Okay, we add this one. I don't remember if added the version. dependency. Oh, so here when I check external library, IO micro, they already have some kind of version. Okay, because they are managed by project. Okay, so here build Gradle. Let's extend this one also. Implementation. At hotel micrometer again. As always, this appender. Refresh. I will copy these metrics, so I will not rewrite them from scratch. Resources. So this time the Spring application name is client. There's different port, same profiling probability Prometheus, and same logging format. And maybe just add will be log Spring. Log Spring example. Here, anything special? Application name. Okay, everything is same. Okay, client also is fine. Right now, there should be client configuration first. So here in Spring application and client application, we will have some kind of configuration. That configuration plus REST template config. They are using proxy. So here there will be a bean definition, REST template, but it is retrieved from builder. REST template builder. Let's import. REST template. Return builder.build. Okay, so if you use REST template builder, there is a couple of more alternative advantage. Something like you can add basic authentication, this kind of. And there is a command line runner. Okay, we will not have the Spring application, but instead here client application, right? Client application. So this will not be a Spring Boot application. Okay? I will put configuration there and there's no static void main. Oh, maybe touch this one. micro, the log here. What is this random user type picker? Okay, they don't mention about this logic. Command line runner. This one. Oh, here in this class. Okay. Okay. If this client content executed, then we should see something like we'll send a request. Yeah, you see, it got a response. It made the request to user endpoint and it got a response. So this is client application. Ah, okay. If I search by this one, what I got is it is saying it is returning the server related stuff. Okay. You see, this is command line runner. So this command line runner, it owns the entire request flow, right? This the long line is the entire request. And you see there's an HTTP GET on the client side. As you can see, there's an HTTP GET here, and there is a server HTTP GET, and there is a getting username span. So you can see the drill down all of the operations. There are two types. All right. Cool. So my take on this, uh, the best practice is, for example, you may ask that, what is the usage of this one? How can I know trace ID of a request? So the best practice is, we have a client server topology. We made a request, and this REST template it automatically propagated all the context to the server side. That's why once we search with trace ID, we could see that log. And when we expanded this log, you saw the attributes, the for HTTP client, for server related metrics, for the specific span inside the service layer. So we saw all the things there. And let's say that you provided an SDK to your customer, or think about there is an web application. When you make a request to the server side, you return a trace ID in the header side. If there is a problem, if you somehow include this trace ID in the problem, saying that, okay, we couldn't get your user data, please create a ticket by using this request ID. Maybe you can do such a thing. Or maybe as a telemetry data, you can ship this event to some kind of backend so that you can further analyze it. By using trace ID, you can see all the services as we saw in the timeline. In order to store these metrics, we have used Tempo, Grafana Tempo. To check the logs, we have used Grafana Loki. And I don't know if there is anything in the dashboard. We only have Loki. Okay. So you can already see this. For example, when I open this one and attributes, the span kind is server. When I open this one and check attributes, this time the span kind is client. Yeah. And you see, in the client side, the SDK implementations are mostly called or prefixed by OTel. So OTel library name, Org Spring Framework boot, library version, this kind of thing. So Spring Boot framework already has this OTel implementation in the client side. What else here? Attributes. This is the start of the trace, and as you can see, there is a user ID, there is a user type. So you can add additional data to this telemetry data. This TP 95. So I don't know if you ever heard about that. There is TP 99, 95. So for example, if let's only show this TP 99, when you check this one, this line, you see 99 percentile metric is 176 milliseconds. That means 99% of my requests are equal or less than this millisecond. So this is called percentile metric. And when you take a look at here, is 31. There's no. Okay. I can say that I like this Grafana stack, by the way. It seems cool. And they are not a huge stuff. Maybe I can also use this one for my projects. Okay, so I think we are at the article. Yeah, so after this, the remaining part all about using native image build, etc., but we already used it yesterday. So that's it. What people says about this, I am posting this comment to explain what I needed to get the demo app running. Okay, it is IDE related. Reactive. No, it compiled for me. Session problem. Okay. Yeah, that was it. So I don't have any other thing to try. So the OpenTelemetry part, again, it's still verbose. Maybe I can try it with default configurations, but at the end, it's working. And then I like the correlation between this Grafana stack and Spring application. So in the upcoming sessions, maybe we can do some session about memory profiling in Java or Go. I couldn't just decide on that. But yeah, that was it. Thanks for watching and see you on the next session.